These lines are perpendicular to one another. These lines are orthogonal to one another. And these lines are normal to one another. So what exactly is the difference between perpendicular, orthogonal, and normal? To differentiate these three seemingly interchangeable terms, we should go to their definitions to find some similarities and differences. Orthogonal is defined as something's at right angles, statistically independent or independent dimensions. The definition of perpendicular means at a right angle to a line, plane, or surface. And the definition of normal is ordinary or usual, but it's also a linear feature intersecting a line or surface at a right angle. Looking at these definitions, it tells us that if something is normal, then it's also perpendicular. And if something is perpendicular, then it must be orthogonal. Orthogonal has a wide array of meanings, but when used specifically in the context of geometry, it is interchangeable with the word perpendicular. The difference between perpendicular and normal is a little more nuanced. For something to be perpendicular, it needs to be involving right angles, or 90-degree angles. And for a perpendicular feature to be normal, it needs to have a linear feature. Some examples of linear features include lines, line segments, rays, vectors, and planes. Some example of nonlinear features include waves, curves, and curved meshes. So two linear features intersecting at 90 degrees. Because they're intersecting at 90 degrees, they're perpendicular, and because they're linear features, they're normal. Here, two nonlinear features intersecting at 90 degrees, or in this instance, their tangents are intersecting at 90 degrees. This is a cosine and minus cosine, and they do intersect perpendicularly. They do intersect at 90 degrees, but because they're non-linear features, they are not normal. What about something like this, where there's one linear feature and one non-linear feature? Well, they intersect at 90 degrees, so it's perpendicular, but is it normal? Well, yes and no. Because the line is a linear feature, then we can confidently say that this line is normal to the curve, but we can't say that this curve is normal to the line. Perpendicularity is transitive. In other words, if A is perpendicular to B, then B is perpendicular to A. Normal, on the other hand, the linear feature is what's normal to the other feature. In conclusion, orthogonal has a bunch of different definitions, or has a bunch of different meanings. Perpendicular is specific to geometry and is in reference to 90-degree angles. And normal is a subset of perpendicular that involve linear elements.